All right, so I want to put together just go over a short example of a limit involving the sine of x over x limit that was presented at the end of section, I think, 2.3. There was this long explanation of this limit that involved a bunch of geometry and trigonometry and stuff, and but now that we know it, we can use it. So the limit was the sine as x approaches 0 of sine of x over x equals 1. That was the limit that was proved. Now, given that as a fact, we can use that for other things. So the example I want to go over is this one. The limit as x approaches 0 of the sine of 5x over x. All right, if there was some kind of trigonometric identity which would allow us to pull out this 5, then maybe we could use that, but there isn't. That 5x in there is kind of locked in. We can't just remove it from the sine function or anything like that. We could apply some sort of, we could write this as x plus x plus x plus x plus x and apply some sort of sum formula, but that sounds like it would get complicated really fast. So there's another way around this, which is to get in here, pull out a different color, get in here and multiply this function by 5 over 5. So I'm going to put a 5 in the numerator and a 5 in the denominator. I think you can all agree that that's still equal to the original function, and therefore it is equivalent. Now we're going to apply one of the properties of limits, which is that if you have a constant multiple of a function, the limit of that is the constant multiple of the limit of the original function. So in this case, let's consider that 5 in the numerator as our constant multiple. We can use that rule, that property, to go ahead and pull that multiple out. So this is going to be 5 times the limit as x approaches 0 of sine of 5x over 5x. So now we're getting much closer, because what we have in here is not sine of x over x, but it is sine of 5x over 5x. And that 5x and 5x, the fact that they now match each other, means that we can use a really common strategy that shows up all over the place, which I like to call U substitution. Basically, it's just function composition. So we can view this as a composition of two functions, and the outer one is the sine x over x function. So what I'm going to do next is I'm going to say, let's let u equal 5x. Now, the limit as x approaches 0 of 5x, okay, this would be the limit of the inner function as x approaches 0. Since 5x is just a simple linear function and it's continuous, this is going to be we'll get the limit value by just doing direct substitution. So 5 times 0 is 0. So that's approaching 0. So what that means is that as x approaches 0, u also approaches 0. So now what we can say is that 5 times the limit as x approaches 0 of sine of 5x over 5x is the same as saying 5 times the limit as u approaches 0, notice the change of variable, of sine of u over u. So I've done the substitution. 5x is now replaced by the variable u, and instead of having x approaching 0, I'm having u approach whatever it should approach. Okay, and that was determined by what we discovered up here, by looking at what u is and taking the limit of that function as x approaches 0 to discover what u is approaching. Okay, so now in this example, it's the same number, but you can imagine in other examples it could be a different number. So just make sure that you're paying attention to that carefully. So this u is approaching 0. That gives us this down here. Now this limit is exactly the same as this limit, except just you're giving the variable a different name, which doesn't matter at all. So it doesn't matter that this is u instead of x, because they're all u's and these are all x's, so the limits are really the same limit. That means this all here equals 1, so we have 5 times 1, and we have 5. So there we go. That limit we started with was equal to 5. So that strategy, that U substitution type strategy, or really like just viewing something as a composition with a little bit of, tiny bit of algebra trickery in order to get there, that is a pretty useful strategy that you'll need to apply on a couple of homework problems, along with potentially some trigonometric identities. There's one involving like cosine and tangent that you can simplify with an identity, but it's one of the basic trig identities. If you need any help with that, just let me know. Hopefully this video will help. Yeah, that's it. That's all I wanted to say.